Alright guys, welcome to this set of videos. These videos are going to go along or follow along with the notes that come from your textbook. It'll be chapter 1, section 5. And what we're going to be doing in this set of videos is working on solving inequalities. This should, again, like most of what we've done here in Chapter 1, be review of some of the things that you guys did in Algebra 1. And specifically what you're going to want to focus on for this set of videos is by the time we get to the end, you should be able to do these things. Your objectives or your learning targets are going to be, first, solving one-step inequalities. So we'll review some of the properties of inequalities, do a couple of example problems, and then after that we're going to go into the second objective or learning target, which is going to be solving multi-step inequalities. So just make sure that you keep in mind by the time we get to the end of these videos, you should be able to do those two things. So here we go. Let's jump right into this. First, when it comes to inequalities, I want you to think of two numbers. Let me give you a second to do that. Think of any two numbers that you want. Doesn't matter what they are as long as they are real numbers. Now, once you have your two numbers, I just want you to jot them down real quick. For example, I like the numbers 10 and 36. Now, whatever your numbers are, doesn't matter what they are, just jot down those two numbers. What I want you to think about is no matter what two numbers you pick, one of these three things must be true. Either the two numbers that you've picked, the first one is smaller than the second one. That happens to be what I have. 10 is less than 36. You may have picked two numbers and said, you know what, I only have one favorite number, so I'm just going to pick it twice. In which case, you would have two numbers, and they are both equal to each other. Or you may have picked two numbers where the first number is bigger than the second number. The idea is here, all I want you to sort of realize, no matter what two numbers you pick, as long as they're real numbers, it's either going to be this one, or this one. And that's the idea with inequalities. Either the numbers will be the same, one number, the first number is less than the second number, or the first number is greater than the second number. Now, before we jump into doing some problems, when it comes to these inequalities, hopefully what you remember from Algebra 1 is that there are three ways to represent a solution. Let me number them for you here. When we solve inequalities, I'm going to ask you here in the notes to do it all three ways. We will give all three of these representations of our solution. In the homework, they're going to ask you for a specific one. Also on quizzes or tests, I as well will ask you for a specific one. But you won't know which one of these I'm going to ask you for ahead of time, and I do use all of them fairly equally. So it'll just be a good idea here in the notes to get as much practice with each of these representations of your solution as possible. That way when you get to the homework, quizzes, and tests, you're familiar with all of them. The first one is going to be inequality notation. This is just what we know. When you solve the inequality problem, your solution, that solution you get by solving the equation or the inequality, is your inequality notation. Beyond that, the set builder notation, please notice you are going to take your inequality notation, you're going to put it inside of braces. All right, so we're just going to put it inside of braces, and then we're going to add this extra little piece right here, and all that does is it just simply tells me x is my variable, so that when the person begins to read set builder notation, they know I'm talking about the variable x. And this little bar right here, this line, means such that. So the way that this would be read is your solution. Your solution are all values of x such that -1 is less than or equal to x, and x is less than 3. All right? That's how you read set builder notation. We tell you what the variable is, such that, and then where the values of x fall in. The last one is going to be 3. This one's really self-explanatory. It is just a continuous number line. The point I want to make here is that please remember that a closed circle is less than or equal to or greater than or equal to. It must have the equal to. The equal to means that you fill the circle in. The open circle means strictly greater than or strictly less than. Because it is not equal to, we leave the circle open because 3 is not included in the solution, right? So x's must be less than 3. So you could have 2.9, 2.99, 2.999, whatever decimal you want, it just can't be 3. So it's everything less than 3. But on the other side, -1 is included. It's everything greater than or equal to -1. So we fill in the circle because -1 is a solution and shade going in that direction. Those are our 3 solutions. We'll get a lot more practice as we go ahead and start solving some of these problems. So head on over to the next page. We'll get started. I'll see you there.